Okay, so I'm just making this for a couple of reasons. First of all, because I think it'll be a good reference for me down the road. And secondly, I think it will help people um, in a similar position to me uh, kind of navigate their way around. Because I think this will provide a bit of a, I guess, opportunity to see kind of my thought process along how I do things. Um, so this is going to be a bit of a developer log for my NES emulator. Um, so I guess I should just give a bit of background. I started work on this around the first or second week of August, and it is now the first week of October. And I spent at least half an hour every day on in August and I guess the first week of September working on this. And ever since then, I've kind of stopped. And school's gotten a bit busy, and I don't know if I'll be able to dedicate as much time to it as I'd like. And that's part of the reason why I'm making this, so I can kind of collect my thoughts back when I do end up resuming this down the road. Um, so I guess I'll just give a bit of background. So this emulator that I've written it in Rust, and I use SDL for the graphics. And as of right now, the CPU is fully done. The PPU is done, although some parts are kind of duct taped together. I kind of want to avoid that phrase, but that's kind of the reality. The APU hasn't been started yet, and I guess that's really all it comes down to. Oh, and then I guess I should mention in terms of mappers, I have NROM, MMC1, and UXROM. So I believe that's it. I'll just double check. MMC1, NROM, UXROM. Yeah, okay, so I have three mappers. So I guess I'll start with the CPU. So in terms of the CPU, everything is essentially done, although I'm getting some bizarre behavior in some games, and I don't know whether or not that is the CPU. It could be the NMI handling. So the CPU is completed, although I don't have the illegal opcodes. All the legal opcodes are available, and all the addressing modes. So all, I believe it's like 50 something legal opcodes are there. A lot of them are really simple. Most of them are actually, and then there's a couple ones that are a bit more complicated. And I learned previously, some did actually cause me trouble that I didn't realize were broken because they passed NES test, which I learned wasn't as thorough of a test as I initially thought it was. And the opcodes in question were add and subtract with carry, and also the bit test ended up not working as planned. But I've resolved all those, and I'm getting some bizarre behavior, like I said, in some games, and that could be because of the CPU. But yeah, in terms of the addressing modes, I believe these, it's a bit easier to verify that they're done correctly, and I believe that they have been. Most of these, again, were pretty simple, although some were not very difficult, but definitely it was a bit of a hike, mainly the indirect, which basically uses, it's kind of like pointers. That's the best way to describe it. Obviously, that's a bit of a simplification, but adjusting modes, I'm almost positive are accurate. I would think the CPU would behave fairly weirdly, and I wouldn't be able to test. As of now, it tests NEStest and Blarg's official test. So I believe the CPU is mostly accurate, although there could be some mistakes. In terms of I guess what would best, I guess I should have kind of gone over the architecture of how I have this laid out. So I guess we could, the best thing to do would be, so I have an NES that has a CPU, and if I go to the CPU has all of its registers, program counter, stack pointer, and the status. Um, and it has a bus attached to it. And then I have a couple of variables here just for emulation purposes. And so if I go to the bus has the CPU's memory, the PPU, the cartridge, and the joypad, and the APU eventually when that ends up happening. And then this DMA page is just for the way I made it so that the PPU could access use the DMA function through register. I believe it's like 4014 or something. So the bus has yes, all these, and I just have my get memory functions, and it does, obviously it accesses different things depending on what memory address is requested by the CPU. And I guess that brings us to the PPU. So the PPU, to account for, I have the PPU's memory here, primary and secondary OAM, name tables and palettes, and the current scan line and cycle. I have these registers. So the registers that actually store 8-bit values, I do keep them as one register. I don't actually split them up into other registers, which I've seen a lot of other people do. Right now, that was just how I started it, and right now I don't have any reason to switch. But yeah, just to explain those, registers 2000 through 2003 hex. This data buffer, that is part of register, that's for writing memory to, that's for the CPU to interact with the PPU in terms of memory writing. And I have these registers are part of the loopy register method of kind of controlling some internal values for the PPU that get modified slightly depending on certain registers being accessed. And in the case of these VRAM and the VRAM address, that gets manipulated as you draw the background. And I also have this is for the background. These are like, I guess I'll group all these together. These are all for in the background for when the NES is fetching the information about the backgrounds for the next the stuff that hasn't been rendered yet. So that updates based on the NTSC timing diagram on the NESdev wiki. Here, this is sort of similar stuff. It's a lot. It's hard to talk about without getting into too much depth. But this is related to Dark Sprites, as is this. And then also I have the PPU have access to the cartridge because the PPU has to communicate directly with the cartridge's character ROM, or RAM, depending on what the header says. But also I have some NMI or current NMI related variables because the PPU can call an NMI to the CPU, and depending on these two variables, the status of these two variables being true or not. And again, these two variables, I guess all three of these variables were found. I did that based off of what the NESdev wiki recommends. This even frame, that's eventually I'm going to use that. Right now it's not necessary. This display vector represents the output, and that's how SDL parses, I guess, just 8-bit integers into an actual display. And this draw is just representing whether the PPU should actually draw or not. And so that turns to true at the end of, well, as soon as the PPU hits V blank. So we only draw once per frame as opposed to every time the PPU cycles, which would be extremely slow and inefficient. These are just allocating default values, nothing really exciting here. And the display vector is the size of 256 times 240, which is the resolution of the NES times 3, because the way SDL parses the information is it has R, G, and B values. So for each pixel, you have your R, G, and B 8-bit values. So this is just assigning the cartridge. These are my methods for or functions for gathering the background information before it's actually accessed, as is this and this. It's just a bunch of manipulating shift registers and storing stuff in temporary variables. My evaluate sprites. Now this is part of the foreground, and the foreground work, when I said at the beginning, some of this is duct taped together. The foreground work on the PPU was particularly what I meant. I was kind of just messing around with it, and it ended up working. And there are still some errors, which I'll get into later. But yeah, as of now, it works in most cases. But there are some minor glitches, mainly with rotations of the sprites. Fetch sprites, same thing, has to do with fetching directly from or I guess it always fetches directly from, but fetches from the secondary OEM, which is gathered from the primary OEM, and does some stuff based on the data of the sprite, which it's the sprite data is displayed in a, I guess, arbitrary format that Nintendo decided, and this is just a matter of parsing it and displaying it in the right way and loading it into their shift registers the correct way. And this is, I believe, where the issue comes from, because the main issue with sprites, drawing sprites, is in very minor, in like very specific examples. I don't know exactly why it is, but the sprite will draw incorrectly, and I'm almost positive it's when the sprite is flipped both horizontally and vertically. And so I have to look at that, but other than that, the sprites draw fine. Oh, and then I guess sprite zero hit is another thing that is a bit duct taped together. I don't know how robust my implementation is of that, but there are a lot of games that are well documented for providing to be good benchmarks for that test. So yeah, sprite zero hit, and that flipping, if the sprites are translated in a specific way, or not translated, I guess, altered in a specific way, that can cause some rendering issues with the sprites. This rendering pixel just renders, or this render pixel method does it for each visible pixel, and it goes from, first it renders the background, and then it renders the foreground. So it is, I guess, sort of inefficient, because if there's a non-background sprite pixel at the front, you don't have to render the background, but I do that anyway, mainly just because it made it easier to come up with a solution while I was still developing it. But yeah, that doesn't do too much. That's just collecting data from the registers. That doesn't actually change any internal values, at least I believe not. And this is just doing palette mirroring, which I believe works, although it's hard to say for sure. It's resolved in most cases. I had some issues with Mario, the original Super Mario Bros., but those have since been resolved. So I also have, I guess this is where the PPU actually starts working, the tick method, and that goes for every pixel. And it doesn't just go through 240 by 256 or 256 by 240. It actually extends both horizontally and vertically past in order to do a couple things. Vertically for VBlank and horizontally so it can get data ready for the next scan line. And so at first I set a couple, this wasn't my idea, this was actually Dan Fogelman's idea, who's had a really good code base for me to reference if I do get stuck. He wrote his emulator in Go, which I don't know that language, but a lot of the concepts, obviously the concepts aren't too far-fetched. So yeah, he came up with this idea that I gracefully put into mine as well. And so he just sets a couple variables depending on the status of the PPU mask register, which is for whether or not it's actually rendering, and then also just depending on what scan line and cycle the CPU is at, and then doing specific things based on that. And so if we go back to that NTSC timing diagram that I mentioned, you do specific actions in terms of fetching background tiles, at certain times, and then also you manipulate your loopy register that I was talking about before at certain times, depending on these variables. So yeah, and also this is for I believe this is for again the NTSC timing diagram. This is for sprite. This is sprite info. So you clear it here. You clear it on this. You clear it and then you evaluate and you fetch on a scan line for the next scan line, and I just do all that stuff there after the background, and then just my VBlank stuff. You manipulate a couple of registers. This is part of the NMI, and these involve modifying those loopy registers I mentioned based on the timing diagram specifications. Depending on mirror mode, doing different things with the memory when you access it, and I believe that's really all the main stuff is to touch on the PPU. And then there's also just these various register functions, which are when certain registers are either written to or read from. And so that kind of covers the second main thing. And the last main thing I'd like to go over is just the status of the mappers / cartridges in general. So NROM is the most basic, and generally it doesn't even have any, it doesn't have the ability to switch banks or anything. So that one's very simple, and as far as I know, fully works. Can't even change the mirroring mode. And most games that use NROM are fairly simple to begin with. There's also, I guess, UXROM, which I should go over next, which has basic bank switching abilities. Some games that can do that are, I guess, some games that come to mind are DuckTales and Castlevania. Can't switch mirroring mode, but yeah, it has basic bank switching abilities. And there's also, and this one I don't know how well implemented it was. I did this in about half an hour, and I saw Castlevania and DuckTales both at least seem to work, so I think that one's okay. And also MMC1, which is a lot more complicated. It can do bank switching, but it uses a lot of really clever tricks. MMC1, a notable game would be The Legend of Zelda, and I don't really want to get too much into it, but basically if you write to certain addresses on the cartridge that aren't actually mapped to, you can, I guess they are mapped, but that's how you do bank switching, and you can get really clever with how you switch different banks, because you can have multiple banks for character ROM and you have a bank for program ROM, and you do it all through a shift register. So you write one bit at a time, and then it feeds through, and then when you write enough bits, it will write to it. So it's pretty. The engineers at Nintendo did a really good job of future-proofing this, but yeah, that was very complicated, and I had some trouble with implementing this. I guess I should just go to my mapper trait, which just has a couple key things. Grabbing the mirror mode, because some mappers have the ability to switch mirrors, and some don't, so you can't just always rely on the header. And then I also have read and write from both program ROM and character ROM, and I guess character RAM as well, depending on what the situation is. In the case of writing, it's always going to be RAM. I dump all my data, all the ROM data, into a data file that I resize to certain specifications based on the INES header format, which I have this header object for. Yeah, this format is very widely used, and essentially it's just following instructions given on how to do. The first, I guess I can give an example. The first 16 bytes are the data that tell the emulator what kind of the deal is with the ROM. So you see these first three here are NES, and then these other ones tell a bunch of details about the mapper, the mirror mode, a bunch of stuff like that, the size of the banks. So that's all I really want to talk about for that. I guess now I'll get into some actual gameplay. So I'll start with Mario. Mario works, at least as far as I'm aware, completely. I haven't actually managed to beat the game yet, but it does work. You can also walk backwards, but that's because the emulator doesn't have the ability to, or I haven't made it. On the actual physical controller, you aren't allowed to press both the left and right D-pad at the same time, but in the emulator you can. And so this would happen on actual hardware if you had the ability to do that. So that game works as far as I know. I've tested it fairly extensively. Another one worth talking about is, I guess, Ice Climber. And also, yeah, by the way you load ROMs is very bad in terms of accessibility. So this game does some very bizarre writes or reads to the program ROM, which don't actually, like, I don't know why it does this. If I use the modulo operator, I don't believe that resolved anything, but the game is fully playable. So I don't know really what the deal is with that. I'd love to find out, but I wasn't able to find any information on that. But it seems to work. It's playable. Another game, I guess Donkey Kong, I should just show it because that is traditionally what's considered the best game for getting your emulator up and running. And that's what I used as my first game to test. So this works as well. I don't want to play a full round, but I mean, I'm sure you get the picture by now. And I guess I'll get into the more complicated games now. So I will do Zelda. So here's where I can show you an example of the sprites not working accurately. Also, I don't have saving implemented yet, so it won't actually save any of the data. But so it does do this vertical scrolling correctly. But when I go, you'll see, if you pay close attention to the enemies here, you'll see these, like, those horizontal lines where they're just completely cut out, and that's not supposed to happen. I think that's because they translate the sprites, or not translate, I keep saying translate, but you manipulate the sprites in multiple ways at once that my implementation isn't robust enough to take care of properly. So those are the games that work fully. There are a couple games I have here that don't work for a variety of reasons. First of all, Super Mario Bros. 3 and 2 don't work because I don't have MMC3 implemented. That's kind of, I would love to get that working. Ninja Gaiden doesn't work. Ninja Gaiden doesn't work. And that, I've never fully understood why it doesn't work. I think it has something to do with my PPU being incorrect, although it could be the CPU as well. So something about the emulation is imperfect, and some games it causes problems, some it doesn't. Ninja Gaiden, it's not startable, but we have games like Duck Hunt, and this I was trying to figure out for a long time, and I still can't, and this is part of the reason why I'm making this video, so I can kind of recall this. Duck Hunt works for the first 2 frames, but then this bizarre behavior happens, and then if I try to start the game, it tries to write to the wrong spot. And if I disable background rendering, it doesn't do that. So it has to do with manipulating the VRAM loopy register address during rendering, I believe. And the reason why it's going the wrong way could be the CPU, could be the PPU, could be the timing being off. I have no idea. But so that is actually an NROM game that doesn't work. Other things, I guess I'll go into DuckTales. DuckTales. And so that one does. So here's a bizarre thing, actually. For every UX ROM game that I've tried, the controls don't actually work, and I think that's because I didn't implement the mapper very well, or at least that's what it seems to be. The controls don't seem to work. But as you can see, the game is running properly. Maybe we'll do a bit of a gameplay demo. Oh, well, I can't pause. So maybe my controls just need to be implemented better, because if I press the left arrow key, which is D-pad left, it seems to pause. I'd have to look at what an actual emulator does, or actual hardware, I guess I should say, to figure out what the correct behavior is. And then I also have Castlevania, which, again, the controls don't work, and there's some rendering issues with I don't know whether this is a sprite or the background. I would assume it's background, but the palettes are rendering incorrectly, as you can see here. And then also you can see another example of this sprite not I'll load it one more time so you can see. But you can see it's like kind of showing double at the bottom, and I think that's because of the it's being manipulated in multiple ways at once that my emulator right now can't handle. So that's about it. In terms of tests, the tests are a bit boring, so I don't want to show them to you. But it passes Blarg's official and it passes NES tests. And that's really all that's relevant to me right now. The PPU tests, they don't all pass yet. But just because my CPU passes all the key tests, I don't really want to assume that the PPU is correct, because that's already been the case multiple times where it did pass and then it ended up still having issues. But in terms of what I want to do next, I'd love to implement the APU and I'd love to implement MMC3, but I don't want to do any of those until I have some of the easier and more other big mappers implemented, and then also some quality of life improvements, such as not having to type in the ROM name manually here to load a ROM, and also fixing some PPU foreground rendering stuff, and kind of figuring out, just in general, figuring out the issue that's causing those problems with like Ninja Gaiden and Duck Hunt. So yeah, hopefully I can absorb some information from this, and you as well. But oh yeah, and then also here I have this really bad method for locking the speed. Don't look too much into that, because it's kind of embarrassing how dumb that is. But yeah, runs well. Some games don't run well. I mean, it runs well in terms of performance. All the first party games I've tried seem to work quite well, other than I think Duck Hunt is first party. But yeah, I believe that's everything I want to go over. Maybe I'll make any follow-ups if there's something that does happen, but that's about it in terms of everything I'd like to go over for the emulator. So yeah, hopefully this provides some good information, and if anyone has any questions, feel free to ask, and I'd love to do my best to follow through on those. All right, thanks so much.